So once again I'm in the garden with the Arduino MPPT solar charge controller test rig, and I've added some software in to read solar panel voltage, solar panel current, battery voltage, battery current, calculate watts on both sides and divide solar panel watts by battery watts to get efficiency multiplied by 100 to turn it into a percentage. And if you look just below the word solar, there's the efficiency percentage. Now this is running at maximum power. Incidentally, sunshine today, so the Met Office and the BBC were quite right. It's actually a beautiful early October day. But we're getting 99 or 100%, and in fact just briefly there it showed 101. So that number's a little bit suspicious, and in fact if I turn this up to 100% PWM, we're now getting an efficiency percentage of 102 or 103. So clearly something here is misreading. It's not a miscalculation, it's a mismeasurement. And if you look at the battery voltage, 12.34. Over on the battery volt monitor I'm getting 12.2. So I suspect that battery voltage is reading slightly high, and as a result it looks like there's more power coming out of this thing than going in. Definitely not free energy. So probably need to subtract a couple of percent from that reading to get a realistic percentage. So if we go back to maximum power, which is difficult to do, show this dial really, shouldn't I? So about there, reading 98, 99, 100. So if we subtract, say, 3 from that, about 96% efficiency. And judging by how warm the buck converter components are, this has been on for a long time, they're just mildly warm. So I would guess that's probably about right, 97% efficient. So at first glance, that's a pretty good result. Now, I remember when I was using the two 20-watt solar panels wired in series, and getting this unit to do quite a large voltage conversion, voltage step down, and therefore quite a large current step up, the efficiency wasn't as good. So I'm just going to wire that up and see what that looks like. So here are the two 20-watt panels, and they're connected through this serial connector so that their voltages are added, and that's going in on the solar panel side. Now maximum power occurs around about 30–40% PWM. Let's just try and max that out. So it's about 30 watts. October, sun, that's not surprising. Should be capable of getting 40 watts from these two panels. But 30 watts at this time of year is about right. And as you can see, the efficiency percentage now is kind of 89–90. Now if we subtract 2 or 3 from that, it looks like this is running at about 87–88% efficient, and that seems about reasonable, I think, because the buck converter is working a lot harder now. It's having to convert, well, let's have a look. Solar panel voltage is 37 volts. It's having to transform that down to 12 volts for the battery. So it's about 3:1, and at the same time it's having to do a 3:1 current gain. Now I can't see current on here, the battery current. It's calculating it, but there's no room to display it on this display. But in fact you could calculate it from the efficiency value. But that seems about right to me. Efficiency of, I would estimate, about 88% in this setup. Now, if you've got an efficiency of about 90%, then 10% of the power is being lost somewhere. And of course, the place that it's lost is in heat. So the buck converter components will be getting warm. It's going to take a while for this to warm up, pushing 30 watts from the panels through it, but that is warm. I can feel that that's warm. The Schottky diode, mildly warm. The MOSFET, sort of between the two. The inductor seems to be the place where most of the heat is generated. And it's possible that that could be solved by an inductor that had, say, thicker wire on a larger ferrite perhaps. But all these things need to be evaluated once the scope has been got onto this thing. So with a 36 cell solar panel, to be getting an efficiency percentage of around about 97 is pretty reasonable, I think, with the 72 cells getting efficiency of in the top 80s. That could be worked on. Again, have a look at how the buck converter is behaving with that large conversion. I did have it in mind that I'd quite like this thing to take 108 cells, so that's kind of 3 12-volt solar panels in series, as a sort of target spec. Quite what the efficiency would be with that amount of conversion, I don't know, and possibly whether the MOSFET would require a heatsink, whether the diode might require a heatsink, and whether the inductor might need to be larger, are all things to be looked at in the coming months.